This video just continues where we left off on solving radical equations, but let's just be reminded of the process. We need to isolate that radical, meaning get it by itself, raise both sides to the appropriate power to get rid of the radical, so square a square root, cube a cube root, raise the fourth root to the fourth power. Then we're going to be solving that resulting equation, and then we have to check for those extraneous solutions. Looking a little bit more difficult or a little bit different, that is not by itself. I need to get rid of that negative 2, so I'm going to add 2 to both sides. And this time I have x plus 2. That is a binomial. And this is what's going to make it a little bit longer when we square both sides. Because I have that square root, I'm going to square both sides. When you square a binomial, that means to write it out twice and FOIL it, and you're always going to get a trinomial. Now the good news is over here, when you square that square root, it just goes away and I get 3x plus 4. But over here, that means x plus 2 times x plus 2. Now if you don't have to write that out, you don't have to, but you better get a trinomial. So when I FOIL this out, get x squared, 2x, and 2x is that 4x, and 2 times 2 is 4. That's what makes this harder. Now again, I have a quadratic, so I need to set it equal to 0. So I'm going to move these on this side. So I get 0 here. Oh, and that's 0. Well, that's kind of nice. And I can still factor it, GCF. Set each factor equal to 0. And again, I have two answers. I have to check both answers. All right, so I have the square root of 3 times 0 plus 4 minus 2. Does that equal to 0? Again, I've got to put the zeros in both of those places. So that's the square root of 4 minus 2. Does that equal to 0? Yes, it does. All right, now I have 3 times negative 1 plus 4 minus 2. Does that equal to negative 1? Let's see, that's negative 3 plus 4. So that's the square root of 1 minus 2. Well, the square root of 1 is 1 minus 2. That also checks. So both are keepers. Neither one is what's called extraneous. But the important part here is this binomial and squaring that quantity. Let's just do one more of those examples where we have to square a binomial. So again, the step is we need to isolate that radical, and you can see that it's not by itself. We need to move the x to the other side. So I need to subtract x. So I have the square root of 30 minus 2x equals 3 minus x. Now we need to raise each side to the appropriate power, which means we're going to square both sides since we have that square root. Those undo each other, and you just get 30 minus 2x. But here, this is where you have to square that binomial. And I'm going to go ahead and write it out twice to remind myself that I need to FOIL it out, and I'm always going to get a trinomial. So 3 times 3 is 9. Then I have a minus 3x and a minus 3x. That's a minus 6x. And then plus x squared. Now since I have a quadratic, I need to set it equal to 0. So I'm going to subtract 30 from both sides and add 2x to both sides. So I have my 0 here, a negative 21, a minus 4x, and a plus x squared. Now I don't know about you, but that just looks backwards. So I'm going to rearrange it and put it in standard form. I don't change any of the signs, just rearranging. Now I'm going to factor that. I think 7 times 3 should work. Make that negative and that positive. And set each factor equal to 0. And solve. Are we done? No. We have to check our answers back into the original equation. Right, so let's check 7. So I have the square root of 30 minus 2 times 7 plus 7. Does that equal to 3? Well, let's just work it out and see. Now 30 minus 14 is 16. Now the square root of 16 is 4 plus 7 is not 3. So that's extraneous. So let's check negative 3. 30, so we have minus 2 times a negative 3 plus a negative 3. Does that equal to 3? Well, remember a negative and negative, that's going to be plus, so that's 30 plus 6. The square root of 36 is 6 minus 3. Yes, that equals to 3. So 3 is the answer, and the 7 is extraneous. So just be careful when you have that binomial, FOIL it out, and you always are going to get that trinomial. Now we're going to leave the traditional looking radical equations, and we're going to see them written as exponents. As you recall, a fractional exponent like 3/2 really means the square root of x cubed. Remember, that's the root and the top number is the power. So even though we have fractional exponents, those really can be radicals. And so we're going to treat those just like we did radicals when we're solving an equation. This time, instead of maybe just squaring or cubing, when we raise both sides to the appropriate power, we're going to raise it to the reciprocal power. Because remember, you're going to multiply those exponents. And what happens when you multiply reciprocals? You get 1. And so that's why they undo each other. When you multiply those together, you get x to the first power. So yes, these are radicals, but they're written as fractional exponents. So again, we need to isolate that, which it is, right? We have all of this. This actually is a radical. It's by itself. And we're going to raise it to the reciprocal power, so the 2/3 power. And again, those are going to cancel out each other. But we have 27 to the 2/3 power. What is that? Well, that means the cube root of 27 squared. I know you know the cube root of 27 is 3, squared is 9. So now we have a quadratic. We're going to set it equal to 0, so we're going to subtract 9 from both sides. Then we're going to factor that. And we're going to set it equal to 0. And we're going to solve. Are we done? No. We have to check. Okay, so we're checking, does negative 8 squared plus 6 times negative 8 minus 7 to the 3/2 power really equal to 27? Okay, a calculator would be nice, but I think we can do it without it. So we have 64 minus 48 minus 7. Let's see, that's 16 minus 7 is 9. Does that equal to 27? Well, let's see. That's the square root of 9 cubed. Yes, that's 27. All right, so now we need to check 2. So let's see, we have 2 squared plus 6 times 2 minus 7 to the 3/2 power. Does that equal to 27? So I have 4 plus 12 minus 7. So that's 16 minus 7 is 9. And we just saw that, so we know that this is also a keeper, so both answers work. So don't be afraid of those fractional exponents. Just work them out the same way as you would radicals. In this last example, we need to be just a bit more careful. We see that the radical or the fractional exponent expression is by itself, so we're going to raise each side to that reciprocal power, which would be to the 3/2 power. And again, we multiply 2/3 times 3/2, that gives x minus 2 to the first power. But I want to look at this. Why is that different than the last example? It's different because that bottom number is even. That's the root. So really what that says is to take the square root of 9 and cube it. Here's the tricky part. When you put in a square root sign that wasn't there, you have to remember to put that plus or minus sign. So we have 3 cubed, which is 27, but we also have negative 3 cubed, which is negative 27. Because of that, we now have two separate equations. X minus 2 equals positive 27, and x minus 2 equals negative 27. That's the tricky part. So I'm going to add 2 and get 29, and I'm going to add 2 and get negative 25. And I need to check. So we have 29 minus 2 to the 2/3 power. Does that equal to 9? Well, that's 27. Okay, the cube root of 27 is 3 squared is 9. That checks. Right? What about negative 25 minus 2 to the 2/3 power? Does that equal to 9? Well, that's negative 27. Well, the cube root of negative 27 is negative 3, but when you square that, again, you get 9. So we have two answers because of that plus or minus sign. So if you have that bottom number is even, you need to remember I've got to do a plus or a minus. So when we have fractional exponents, again, we're going to raise each side to the appropriate power, and that appropriate power would be the reciprocal.